Hello, pre-algebra students. In Chapter 3, Section 6, we are going to be talking about probability and odds. So in our box are many terms that we need to get straight in order to solve our problems. So you can measure the chance of an event happening, and that's called probability, the chance of something happening. So the first type of probability is theoretical probability. And in theoretical probability, it's the chance that something should happen. So in theory, you should have blank number of favorable outcomes divided by the number of possible outcomes. Now this is going to get very confusing, so just bear with us. Next is experimental probability, where you actually are conducting an experiment. I meant to change colors. So in experimental probability, it's what actually happened when you did the experiment. So it's the number of favorable outcomes, again favorable, divided by the actual number of outcomes that happened. So again, in both, the key word is favorable divided by number possible, favorable divided by the actual outcome. Okay? Then there's another word called odds. The odds in favor of an event is the ratio that compares the number of ways the event can occur to the number of ways that the event cannot occur. So the odds, you say the number that can compared to the number that cannot. Then there's also odds against something happening. So that's when we measure the ratio that compares the number of ways that the event cannot occur to the number of ways that it can occur. So you have to just pay attention to, are we wanting the odds in favor of or the odds against? So as we try to sort out all of these definitions, we will refer back to our important box. So the first example we have is a bag of marbles, and it has 6 red, 1 blue, and 3 yellow. 1 marble is selected at random. Find the theoretical probability of each outcome. So the theoretical probability of drawing a yellow marble out of the bag. So how many yellows were there? There were 3 yellows. So there are 3 favorable outcomes, and we had to add up 6 plus 1 is 7 plus 3 is 10. So we have 10 total marbles in the bag. So 3 yellow out of 10 marbles is a 30% chance, or a probability of 30%. Example B wants us to compare blue or yellow. Well, now there's only 1 blue and there's 3 yellows. So 1 plus 3 is 4. So 4 marbles are winners, are favorable. 4 of them are blue or yellow, and we still have 10 in our bag. So that's a 40% chance. And then C says, what are the odds in favor of picking a red marble? So the odds in favor means we're going to compare the way that it can be red compared to the way it cannot. We're comparing the way it can, not can. So we're comparing can occur to cannot occur. So how many marbles were red? Let's go back. 6 are red. How many marbles are not red? Well, out of 10, that leaves us with 4. 1 blue and 3 yellow. So 4 are not. So the odds in favor of pulling a red marble, let's simplify that fraction, is 3 to 2. You can write it as a fraction or you can write it as a ratio. The odds are 3 to 2. In example 2, it says 10 marbles are selected from a bag of colored marbles, and the results are shown in the table at the right. In other words, they did an experiment, and this was the results of their experiments. So this makes experimental probability. We actually tested it, and this is the outcome. This is the data we collected from our experiment. Now we know why this is in chapter 13. So again, there are 10 marbles, so total possible outcome is 10. And we're comparing favorable outcomes. So when they actually did the experiment, only 4 turned out to be red. So based on our experiment, it's going to simplify 2 out of 5, which gives us 40%. So there's a 40% chance, according to our experiment, of drawing a red marble. You understand the difference? They did the experiment, whereas before we just knew how many colors were in our bag. Alright, for the exercises at the bottom of the page, it says a bag contains 5 red marbles, 5 blue marbles, 6 green, and 8 purple. So that's a total of 24 marbles. And they're asked, oh, wait, there's 1 white marble. Whoops, whoops, whoops. So that's 25 total. Don't get in too big of a hurry like myself. 1 is selected at random. Find the theoretical probability of each outcome. So I'm going to do, how about I do number 2, and I'll leave 1 and 3 for you. White, blue, or green. So how many white are there? There's 1. How many blue? There were 5, and there are 6 green. So that's a total of 12 out of our 25. So I don't have a calculator handy. Let me see if I can find one. Alright, so that gives us 48%. Remember, 0.48 is the decimal form, and so times 100 to turn it into percent. Go ahead and do 1 and 3 for me before you come to class tomorrow. Alright, and on the back we're still talking about theoretical and experimental probability, and here we're going to use a sample to make prediction. To make a prediction about an event that will happen in the future, take a sample or a survey of all of the outcomes. Then use the experimental probability to predict how often that event will happen again. So again, it's here in chapter 13 because it's talking about taking a survey, collecting data, and then we're going to use that data to calculate the experimental probability. So here we have an example. Just like BJ loves his sneakers, we're doing a shoe example. The chart to the right shows the number of people wearing different types of shoes in Mr. Thompson's English class. Alright, so 12 students wear low tops, 7 wear high tops, 3 wear sandals, and 6 wear boots. Well, suppose that there are 300 students in the cafeteria. Predict how many would be wearing low top sneakers. Okay, so we're basing this off of Mr. Thompson's English class. So first we need to figure out how many people are in Mr. Thompson's English class. And they've done the math here for us. So there's 28 total. So I was going to add them up over here. 28 students total. And low top, that was 12 out of 28. 12 out of 28 is 3 out of 7, or 43%. So we're going to assume that Mr. Thompson's English class is a good sample of what most kids in the school would do. So using that 43%, we have to figure out how many out of 300, oh, this is a blast from the past, part out of whole is over of, how many of the whole class, of the whole school, or those students in the cafeteria, is 43%, and percent is always over 100. So part out of whole. When we cross multiply, we find out that about 129, it says here to mentally divide. You'll have your calculator. So, but you could do mental math because it was 12,900 divided by 100. The zeros would cancel. So about 129 is our prediction of how many kids would be wearing low-top sneakers. All right? I would love for you to think about this next problem. Pause the video for a minute and read it through. Again, I'm going to do number 2 and number 5, and I'm going to leave the ones on the outside for you to do. So they surveyed 100 drivers, and they found out how many drove cars, how many drove trucks, and how many drove vans or motorcycles. Then we're trying to predict out of 5,000. So first we had 100. So trucks, there were 43 out of 100 that drove trucks. So that's 43%. So out of 5,000, I have to ask the question, how many, N was the example they used, it could be X, how many out of 5,000 if I projected that it's going to be 43%. So when you cross multiply and divide by 100, you end up with 100N equals 43 times 5,000. Divide by 100, divide by 100, and 43 times, let's cancel out the 2 zeros, 43 times 50 gives us 2,150. That's how many should drive trucks based on our survey, our experiment. Okay, so that was all number 2. I'm going to scoot over here and do number 5. Now it's a truck or a van. So trucks were 43, vans are 12. And 43 plus 12 is 55. And there were 100 originally surveyed, so I predict 55% from my experiment. Drove a truck or a van. So you can either set up a proportion, or if you remember, we also learned that part equals percent as a decimal times the whole. And that was a shortcut when we needed part. So I'm going to go ahead and say 0.55. That's the decimal for 55%, times my whole, which was 5,000 people surveyed. And that will more quickly tell me that it should be 2,750 people driving a truck or a van. So this, I am pulling this equation from our past lessons, or when in doubt, you can always set up a proportion and cross multiply it out. So tomorrow I'll be checking some from the front and 1, 4, 3, and 6 from the back. Y'all have a great day.